All right, now we're going to talk about the rules of exponents. So the first rule we're going to talk about is called the product rule. Remember, product is the name of the answer when we multiply things. So what we're talking about then with a product rule is when we're multiplying and our bases are the same, we keep the base and we add the exponents. Okay? So let's look at that. If we had, say, x is 2, well, 2 squared is 4, and 2 to the third, 2 times 2 is 4, times 2 is 8, and we get 32. If we multiply the bases, that's not what we'll get at all, because now we would have 4 to the fifth, and 4 times 4 times 4 is already 64, and I didn't even get up to that was only time to the third power. So do not multiply your bases. The base stays the same. Excuse me, I didn't write that in here. 2 to the fifth is 32, but that's how we... Wow, I've kind of really messed this one up. Let me redo it just so I can show this to you. If we do it this way, we've got 2 to the fifth, which equals 32. When we do this, 2 squared is 4, and 2 to the third is 8, and when we multiply those two, we get 32. So remember, keep the base, add the exponents. All right, moving on. The next one is called the negative exponent rule. So remember, when we have, say, 5 squared, that means I'm multiplying the base by itself, the exponent number of times. So 5 times 5. But what if I had 5 to the negative 2? There is no way to multiply 5 by itself negative 2 times. That's just not possible. So here's the thing again. Very, very important to know what your base is. Also, before we start talking about that, know that the negative in the exponent never, ever, ever affects the sign out here. They never have anything to do with each other. Now, when we have negative exponents, the base of that exponent gets to move. Only the base of that exponent gets to move, either down or up. In this case, it's already kind of in the numerator since it's a whole number, and so it will move down to the denominator. When it moves down, nothing is left in the numerator, and so we leave a 1 there. The base goes to the denominator, the exponent follows it, but then it becomes positive. And so now, 5 times 5 is 25, and so 5 to the negative 2 is really 1/25. Okay? Again, we need to be very, very careful about what is in the base, what the base is. So also, let's just look at this. If this started in the denominator, remember, it either moves down or up, depending on where it is, and only what has what is the base of that negative exponent gets to move. So in this case, the 5 would move up to the numerator. Exponent goes with it, becomes positive now, and so our answer here would be 25. Now let's look at okay, so turn off the video for a second and you just, oops, this should be negative, okay, 2x to the negative 3. So you go ahead and decide what this is going to look like when it's finished. So when this negative 3 reaches out, the first thing that it touches is the x. not the 2x, just the x. So only the x gets to move. So the 2 is staying in the numerator, the x gets to move, and the exponent comes with the x and becomes positive. And so there, that is our final answer. If this had been like this, now the 3 reaches out and is touching the parentheses, so the negative 2 is our base, so all of that gets to move. There's nothing left in our numerator, so we leave a 1. And do all the calculations, and that's what we end up with for our final answer. All right, let's talk about the quotient rule. Quotient is the name of the answer when we divide. So just like when we were doing the product rule, if two things were being multiplied, we kept the base. If the bases were the same, we kept the base and added the exponents. Well, in the quotient rule, we're going to subtract our exponents, okay? So these bases are the same, so I keep the base and I'm going to subtract these two numbers. Well, 5 minus 3 is 2. Because the 5 is the bigger number in the numerator, that means this guy's just going to stay in the numerator, okay? If this had been the other way around, oops. Okay, again, these bases are the same. I'm dividing, so I leave x, but because the bigger number is in the denominator, that's where my x is going to have to end up being, but I still just subtract the numbers. 5 minus 3 is 2. That's the quotient rule. Then we have something called the power rule. So, okay, remember the definition of exponents is multiply the base by itself the exponent number of times. So my base here for this exponent, when he reaches out, he's touching the parentheses. That means my base is the 2 to the third. Well, I'm just going to multiply these two, and so I get 2 to the 6th. Well, let's look at that if we were to do the rule of exponents. That would be 2 to the third times 2 to the third. And this now is the product rule, so we keep the base, add the exponents, and we get 6, exactly the same. So if it's a power to a power, we're going to multiply them. If we're just multiplying, then we add the exponents. Last thing for these rules, anything to the first power equals that anything. So I could have 57 to the first power. My answer is 57. Anything to the first power equals 57. Excuse me. Anything to the first power equals itself. I was looking at the 57. The other thing, anything to the 0 power equals 1. So just know if you've got anything to the 0 power, it just equals 1, no matter what. So if I had 57 to the 0 power, that equals 1. Or if I had all of this, because it's all inside of parentheses and the exponent on the outside is 0, you don't need to worry about any of that. It just all becomes 1. So anything to the first power is just the anything. Anything to the 0 power is 1.